Hello there. So let's look at today's Leetcode challenge question. It's called online stock span. We need to implement a class stock spanner, which will be updated with daily stock prices. And after the update, you will be able to return the span of the stock's price of the current day. The definition for the span is as follows: the maximum number of consecutive days starting from today and going backwards for which the price of the stock was less than or equal to today's price. That's quite mouthful, so let's actually just maybe draw a picture about actual changes in the stock price to work on a few examples to see what it actually means. So I'm going to use the horizontal line to indicating the days. Day 1, day 2, day 3, something like this. Maybe the stock price is rising in the beginning, and until day 4 it's always increasing. Then maybe day 5 it starts to drop to sudden drop to some lower number. Then day 6 it's kind of stabilized, and day 7 it's on the rise again. Now let's think about if we just updated day 7, we want to calculate this span. It's basically if we put a vertical line here, ignore the stuff on the right. That's not counted because we haven't seen the new days yet. That's in the future. We just look in the left, and we want to also pretty much draw a horizontal line that's separating this today's price with the price that's larger than today's price. Just go towards the left and count how many of those little bars we can have before we find a price that's higher than this horizontal line. So we find that we can count 3, so we return 3 for this given day. Then let's just looking at another example. Maybe we continue on this stock, monitoring the price of the stock for day 8 and day 9, where the price just keep rising. So for day 8, the vertical line, the horizontal line will look like this. So if we count the number of little bars before we find something that's above the line, it will be 4. So 8 has the span of the price for the day 8. The span would be 4. Let's just look at one last example. Let's say that we have really good quarterly reports. The price on day 9 goes really high, and so for that reason the bar will be even above this. That means it's pretty much above anything. Then we count the number of bars towards the beginning. So it's a 1, 2, 3, 4, 5, 6, 7, 8, 9. So then we return 9. So that's what the span means. It's basically having today's price as a cutoff and looking towards the left until we find something that's higher than the cutoff. We count the number of days in between. That's the definition for span. So we have a little bit understanding about this if we look at pictures. This is a little bit mouthful. The example, we have 100, 80, 60, 70, 60, 75, 80, 85. So it's decreasing, going up. So we can actually have something that's interesting on the day 4 here. And going down again, that pretty much resets because 70, there's nothing, because we have something that's above the line with set it by 70, so this resets to 1. 75, the bar rises up higher, so we can actually take 3. And if 85, that's higher than this 5, so the total is 6. So the answer for this example is 1, 1, 1, 2, 1, 4, and 6. So that's the answer for this example. So I guess the brute force solution is just going to be keep the whole thing and whenever we insert one thing, we just look back until we find some price that's higher than today, and we just return the number of elements we look back to as the span. That's just using the definition. It's going to be slow because if we have a lot of stock prices numbers, like huge numbers with potentially a lot of up and downs, every time we have to look back, it's going to be worse. It's not good. So we need something smarter. So let's look at the picture again. So if we are at a day 9, if there's something that the day 8 can provide us that can ease our effort into looking back all the way day by day. So there is actually something that we can do. We can basically, in day 8, we summarize the span for day 8 and also the price for day 8. So let's just because if we ever to have something that's that will actually use these 3 days from day 6 to day 8 to form a new span, that day's price is going to be at least higher than or equal to day 8's price. So instead of keeping track of these 3 values, consecutive values from 6 to 8, we can summarize that into day 8's price. Let's just say it's 3, and if you have something that's larger than 3 price that's coming after the day 8, you can effectively just directly add 3 days and skip this 3, go back to this day 5 here. So that way we can sort of like doing compression along the way we process remembering these prices. So another example would be if we are at day 4, instead of keeping track of day 1, day 2, day 3, day 4, we're gonna keep track of we're gonna compress this upward trend to be day 4's price, which is 4, and it actually also have 4 days. For whenever we have a downward trend, then we couldn't really compress anymore because those downwards are doing resets. So for day 5, we're just gonna put 5 and 1. So with this, we can instead of storing all the numbers in as it is, we are doing a little bit compression. So that when we look back, the calculation can be much simpler. So that's pretty much the idea behind this approach. So to maintain this compression, we can use a stack. Whenever we see something that's larger than prior's day, we can basically compress the 2 days into one thing. So just as example, we have day 1 with price 1 and day 2 with price 2. So once we process the day 2, so initially when we just have day 1, we just put instead of only putting the single price there, we put 1 and 1. That's the current span. Then when day 2 comes in, which has a value of 2, we will pop this out and store 2 in there, because on day 2 the price is 2 and the current span for that is 2. Let's actually do some downwards, I guess. If we have day 3 to be 1 again, day 2, day 1, stack at day 2 is this. Stack at day 3 thinks that we are now having a downward day. The span, the continuously increasing span, just ended there. We have to reset, so the stack will be 2 2 and 1 1. So yeah, so the idea is just using stack to keep track of the price history, and we're gonna do compression whenever we can. When we do the compression is done when we have the current day's price to be larger than or equal to prior's day. That means we can expand the previous span to be even longer. So let's say that just for the sake of demonstration, let's say that on day 4 we have a price that's 3. We're gonna look at the previous current striking kind of span values. It's 1 with the price 1. So the first thing we can do is to of course to expand this span here. Let's say draw a picture there. We can extend this current span with 1 day to be 2, because we now see a price of 3. Then what we can also do is to check on the prior's span, which actually ends on something that's lower than the today's price. So we can actually combine those two spans into one. Then we end up with a span with the high point 3 and 4 days under the belt. After that, we can continue to process day 5. If the price dropped to 2, the stack at day 5 will be this, and a 2 with the current span strike of value 1. So that's pretty much how we maintain this stack. Yeah, so let's just code this thing up. Just for this context, let me just call this the spanner, which is I'm using a vector. It will store the pairs integer to integer. It's going to be the horizontal the horizontal line that the current day's price is going to set on there, and the second element is the number of days that's below that line towards the left before we find something that's even higher. So that's what this tuple here stores when we look at this picture. So for example, here it will be today's price, that's this line, and how many days towards the left we can include under the line before we find something that's higher than this. So for this, it will be price and number of days or little bars. So that's going to be the stuff we keep on this stack. The constructor basically just set this to empty, and then when we get the new price, we would try to do this compression. So in the case of it's decreasing, or if it's the first day, you're gonna have a current strike value of 1. So that's the default. Just call it span. The thing we need to do is to look at the stack, and on the top, that's the previous previous span. So it's, based on this example, we see that we can actually do 2 compression, one with the current value with the prior span. Then we find that the 2 current span can be further consolidated. So it's not a if condition, it's a while condition here. So this means we can do some compression. The thing we do is to grab to expand the span. And then throw out this back element. After this compression, we can put the consolidated path onto the consolidated span information onto the stack. current price and the current span. So that's the code. So let's submit this. Yeah, it's working. On picture, it basically is maintaining for any given day. We draw a horizontal line and looking back, try to compress everything that's under this horizontal line into a tuple with today's price and how many of those dots. So this is the stuff that we put on the stack, because all these little individual details after we are passing today is irrelevant. The only thing important is just the price and how many little bars under the horizontal line before we find something that's higher. So that's the only thing that's important when we calculate the new span for the following days. So the space complexity for this is I guess in the worst case it's all decreasing. We're gonna have the price with one pairs of price and one all the way towards the end, so it's order of n. And in terms of time complexity, it's I think amortized. It will be one. So on some of the days we will just do constant work, but on some days when we need to do the compression, we have to go backward and do some consolidations. It will be let's say that the worst case will be going down all the way, and in the final day we have something that's really high, and then the compression will take order of n time. That's the worst single operation case. Because we have to go back and add one more day, add one more day to consolidate all these tuples on the stack. That single operation will take order of n, but throughout the lifetime, average uses of this operation, I think it's a constant. Yeah, so that's the question today.